Hi everyone, are you ready to do derivatives? I have a whole bunch of examples of a variety of different types of derivatives, and we're going to cover them all in this video. So the way we're going to do this is very rapid fire. So I'm going to show you the function, and you can pause the video and try to find the derivative. I'm not going to do a lesson on any of the different rules, so it's expected that you have a basic understanding of derivatives already. And this is a video for you if you just want to practice. So for our first round of derivatives, I started off pretty simple just to get your brain warmed up and get used to doing the product rule, the quotient rule, and the chain rule. Let's get into it. Our first function is y is equal to x squared plus 3x plus 5. Pause the video and try and find the derivative. The derivative of this function would be 2x plus 3. How did I do this? Well, I used the power rule. All right, now let's move on to the next one. Fair warning, it's a little bit more complex. So pause the video and try and find the derivative. Now, because this function was raised to the power of 1/3, you would have had to use the chain rule in order to find the derivative. All right, let's keep going. Time for our third function. Pause the video and let's try and find the derivative. I hope this one wasn't too tricky for you. The big thing that you need to remember is that we use the quotient rule. All right, we're almost done our first round. So for our fourth function here, I want you to pause the video and try and find the derivative. Now for this function, you would have had to use the product rule in order to find the derivative. All right, now we're on to our second round of derivatives. I hope you notice that it's getting a little bit tougher because now we're working with our trig functions like sine, cos, and tan. So starting with our first function here, y is equal to x squared sine x, I want you to pause the video and find the derivative. Now the key thing for you to remember is that the derivative of sine x is cos x. You would have also had to use the product rule in order to find this derivative. Now let's move on to our second function. So pause the video and try and find the derivative. Now there's a few things you have to remember here. The derivative of cos x is negative sine x. And because this function was raised to the power of 1/2, you would have had to use the chain rule in order to find the derivative. All right, now let's move on to our third function. I want you to pause the video and try and find the derivative. For this function, you would have had to use the product rule, the chain rule, and you would have had to recognize that the derivative of cos is negative sine. And finally, let's do our fourth trig function. I want you to pause the video and find the derivative. Now, this is not that difficult if you can remember that the derivative of tan x is secant squared x. Now, I did want to show you a different way to do this because tan x is also equal to sine x over cos x. So we could rewrite the function like this. Now, I want you to pause the video and try and find the derivative. Hint, you should use the quotient rule. And now when you get your derivative to this point, I want you to remember your trig identities because sine squared x plus cos squared x is always equal to 1. And with that, you'll be able to get the exact same answer that we did in the first method. And you may be saying, that's not the same answer as what we got in our first method. But it actually is, because what is secant squared? Well, it's just 1/cos squared. And now I just wanted to show you that because it's always good to remember that there's different ways to get to the same answer. All right, now we're ready for round 3 of our derivatives practice. I hope you can tell that now we're working with the natural logarithm and some exponential functions. Specifically, we're looking at exponential functions where the base is e. So we have e to the x, where e is Euler's number. I may be pronouncing that wrong. All right, let's get into it. Starting with our first function, I want you to pause the video and try and find the derivative. So for this function, we were working with the natural logarithm, so ln x. And you have to remember that the derivative of ln x is 1/x. Now let's move on to our second function. I want you to pause the video and try and find the derivative. Now I want to talk about this one a little bit because what I did to this function is I simplified it before I found the derivative. When you're working with the natural logarithms, you can use a few different rules. Specifically, we use the power rule, which told us that we could take that exponent of 1/2 and move it to the front of the natural logarithm. And for those of you who didn't do it that way, you can still get the exact same answer. I'll show you here a different way of getting to the exact same derivative. In this case, the only difference was that I had to use the chain rule for an additional step. All right, now let's move on to our third function. I want you to pause the video and try and find the derivative. Now, I hope this one wasn't that difficult. All you needed to know was the chain rule. Alrighty, now it's time to move on to our exponential functions, which contain e to the power of x. I want you to pause the video and try and find the derivative. So for this derivative, you would have used the product rule, but the key was remembering that the derivative of e to the power of x is just e to the power of x. All right, we got one more function. I want you to pause the video and try and find the derivative. This was another example of functions which contain e to the power of x. You would have just had to use the quotient rule in order to find the derivative. All right, now we're on to round 4 of our derivatives, and we're working with our logarithmic functions. So I want you to start with our first function here, pause the video, and try and find the derivative. Now, the key to this derivative was understanding that we're working with a log function, and the derivative of a log function is always 1 over x ln a, where a is the base of your log function. In this example, the base was 5. Let's move on to our second function. I want you to pause the video and try and find the derivative. Now, what I hoped you'd see in this function is that we can use our log rules, specifically that power rule, which told us that we can take the exponent, the power of 3, and move it to the front of the log function. Don't worry if you didn't do this, you can still get to the exact same answer. I just find this is a little bit easier and a little bit more simplified. Alrighty, now it's time to do some exponential functions. I want you to pause the video and try our first function here. Now for these exponential functions, where the base is some number a, you have to remember that the derivative is going to equal a to the x, so your original function, times ln a. And for this example, you needed to be a little bit careful because we also had to use the chain rule. All right, and we'll just end with our last example here. Pause the video and try and find the derivative. I hope this was pretty easy because it was pretty much the same as the previous question. All right, you guys are doing great. We only have 2 more functions left, and I will give you fair warning. These are by far the trickiest questions because you will need to use logarithmic differentiation. So let's start with our first function here, x to the power of cos x. Pause the video and try and find the derivative. Now, the key thing when you're doing logarithmic differentiation is that you need to know your log rules, specifically that power rule that I've been using throughout this video. So what we did is we took the natural logarithm of both sides of our equation. That allowed us to use the power rule and move that exponent of cos x in front of the natural logarithm. And then from there, you're going to take the derivative of both sides. Now, on the left side of the equation, you'll have to find the derivative of ln y, which would be 1 over y times the derivative of y. And then on the right side of the equation, you just find the derivative, just like we've been practicing. And then you have to remember to isolate for the derivative of y. So you'll have to move that 1 over y onto the right side of the equation. Once you've done that, you have to replace y with the original function. And that's a quick little crash course on logarithmic differentiation. Let's do one more example to practice this. Now, I hope this wasn't too difficult. We were just doing logarithmic differentiation, exactly what we did in the previous example. Whew, good job. You just made it through so many different derivatives using all of the different derivative rules. If you were able to answer all of these questions, give yourself a pat on the back because that's really difficult and means you're very good at derivatives. If you did struggle, no worries. These were very difficult questions. My advice to you is practice, practice, practice. It's the only way to get better at derivatives. Anyways, thanks for watching, and I hope you have a great rest of your day. See you next time.